During one of our lectures this semester, a professor proposed a question to the class, and the question was, what do you as a chemical engineer tell people you do when they ask you?
When you meet new people that are not engineers, assume you still have a private life. What do you tell them you do? Do you lie and say you're an architect to keep the conversation going, or... Sorry? You suffer. You might get weird offers with that job description.
And upon hearing that question, the majority of the class laughed, and the reason why they laughed is because it's kind of difficult to explain what you do as a chemical engineer, because it's so broad and you can go into many different industries. And so today I want to speak about what is process design, how it defines a chemical engineer, and how UCT specifically teaches their students process design. I should say how UCT teaches their students anger management, right? Insomnia. Process design in chemical engineering is about designing or using the most efficient way to turn raw materials into valuable or desired products. The career of a chemical engineer is not to just design processes to achieve these outcomes, but the core aspect of the job is to do it safely while minimizing effects on the environment, and while reducing costs and making sure the process runs smoothly and efficiently all year round. For example, creating process to treat and purify water, creating processes to develop and manufacture pharmaceuticals, and specifically my field of interest and my science elective is to create and design processes to refine minerals and oils, minerals and crude oils specifically. In my second year of chemical engineering, we did 2 design projects, one in the first semester about designing an anaerobic digester for a rural community, and one in the second semester about equipment and a pipeline design for an acetone production plant. There are 4 core steps in process designs that are the building blocks for most of our everyday products. So let's dive in with reference to acetone production. Step 1 is design basis. The first step is to figure out what we're making and why. For acetone, the goal might be to produce high purity acetone for industrial and cosmetic use at a specific flow rate, let's say 1,000 tons per year. The flow rate is important because it defines not only the company's demands, but it defines for the engineer the scale at which the process needs to be designed for. Step 2 is process flow sheet development and integration. I would argue this is the most important step and broadly what UCT teaches its students when it comes to project and project week. This step involves creating a process flow sheet diagram, aka a PFD, which is like a blueprint for the entire processes. This involves choosing the right equipment for the process, where the feed comes in and leaves, which equipment is for separations, if there's a pump needed, if there's a compressor needed, basically everything that the process requires, the process flow sheet diagram outlines. Choosing the right equipment and materials is critical at this stage because every piece of equipment and process requires a specific temperature and pressure to ensure that the process is maintained. For example, acetone is an extremely corrosive substance, so when we're choosing materials for equipment such as reactors and distillation columns, you need to choose equipment materials that's corrosive resistant to acetone, as the wrong choice can lead to safety failures, inefficiencies, or costly failures. Step 3 is equipment design. And that's right, we design equipment. And I say that with emphasis because most people get surprised when they find out that chemical engineers actually design. But broadly, most of our calculations is for designing of equipment. And this is where calculations come in. What size does the reactor need to be in order to achieve the demand of the acetone production? We size. What size does this distillation column need to be in order to achieve the desired purity of the company? We size the distillation column as well with the right number of stages. What size or how much power does the pump need to be in order to pump the acetone throughout the plant or to the desired location? We size that as well. Step number 4 and the last step in the core processes of process design is costing. Time to talk money, which is the most important thing when it comes to process designs to companies. There are 2 types of costing involved within costing processes, and that is capital costs and operating costs. Capital costs involves the cost of the equipment itself. So once we are done designing or sizing equipment, let's say we require a reactor to achieve the desired 10,000 tons per year. Required acetone production plant is, let's say, 1,500 liters. Remember, these are all hypothetical values, but let's say it is 1,500 liters, and the capital cost of that specific reactor is, let's say, 200K. That's what we have. Then we need to figure out how much electricity and what's the operating cost of that specific reactor as well. And we do this for all of the equipment involved in the process flow development sheet that we developed earlier. This includes the reactors, the pumps, the distillation columns, basically every piece of equipment. We figure out its costs, both its capital and its operating. A little disclaimer, this video primarily explains to all in a very basic manner the core of chemical engineering. I never go into any earning potential in this video because the career path of chemical engineer is still very diverse. I mean, with a few bridging courses here and there, you're even capable of having your master's in finance just by having a Chem-Eng degree. So please don't think what I explained in this video is what you'll do when you get a job. What I explained is the answer to the question of what is the core of chemical engineering, and I hope you send it to the next person who asks you what you do as a chemical engineer. I know it's been a while since we spoke, and to be honest, it's been a rough year and I did not have enough time to make something I was proud of, but I hope you know I never give up. Don't forget, he who perseveres will always overcome.